Okay, so I think I talked about this just a little bit different in class, but I will make the point again, we don't care about the numerators. Even though they can be factored, and even though it's possible that you could perhaps make some phantom ones out of that, but I'm not concerned about that. The domain of f of x times g of x, we would be concerned though with at least the denominator of f of x, right? So that'd be negative x minus 1. Now, if you think about those two, functions, okay, so let me step back for a second, okay? In fact, let's go back here. So if I were to show f of x times g of x, all I would do is I would take f of x, which is this, and I would take g of x, which shows this, and then I would multiply these two together. Now, from here, it would be essentially fraction multiplication, but we still wouldn't worry about the numerators in terms of the domain, because that's all I'm looking for here is the domain. I don't really care about simplifying these. But what we end up with is we have the f denominator, the function f denominator, but we also have the g function denominator as well. Those two are being multiplied, and what we cannot have, this goes back to some 990 stuff, is I cannot have this be 0, and this would be a factor, and I cannot have this factor be a 0 either, because if they are, anything times 0 is 0, we cannot have zeros in the denominator. So what this allows me to do is it allows me to set up two different equations. I got negative x minus 1. I know it cannot equal 0. Okay, so and then in solving this, let's go and solve this. I'd say go and add 1 to both sides. So then negative, I'm going to show it as negative 1x cannot equal 1. But then divide both sides by negative 1 tells me that x cannot equal, in this case, well, negative 1. Okay, so negative 1 cannot be in the domain. Everything else can. And then also we have the g side of that f of x times g of x. So that would be 2x minus 2. This also cannot equal 0. So from here, I would say, just like we did before, solve this like we would a system. No, not a system. I would solve it like an equation. I'm going to add 2 to both sides to zero that out, drop the 2x. Now cannot equal 2, then divide both sides by 2. So these almost look familiar, right? Because now I have x, it cannot equal 1. They are different answers though, okay? Now, just to emphasize what we just did right there, I found that x cannot equal 1, and I found that x cannot equal 1. It can't equal 1 because of this part of the overall function, f of x times g of x. Because if you say negative 1 plus minus 1, it really ends up being 1 minus 1, and then this denominator would be 0, and 0 times this would still be 0. You cannot have 0 in the denominator. So what about the 2x minus 2? Well, if you replace it with 1, 2 times 1 is 2, minus 2 is 0. Again, this would make this factor 0, and 0 times this, whatever it is, doesn't really matter. 0 times anything is 0, so we'd still have a 0 there. We cannot have zeros in the denominator, so we have found, then, that x cannot equal negative 1 or 1. So those values are excluded from the domain, right? Now I'm going to do this two ways because it didn't specify which way that it wanted. So let's go and do this in set builder notation. Okay, so I got my fancy brackets, x such that x cannot equal, and we have two values from here. We got the negative 1. I'll try to color code these, but also we have the blue 1. Okay, so these are the values that x cannot be. Which, I guess, that's the next part, right? Saying what the domain is all real numbers except, well, x equals negative 1, and also x equals 1. But I'm going to show this in interval notation. But for me, when I need interval notation, I like to have number lines. So I have 0, and then to the right would be 1, and to the left would be negative 1. Okay, now these values are not included, so I'd have an open circle at negative 1, and I would have an open circle also at 1, and then to the left, everything else to the left of negative 1 is good, everything between negative 1 and 1 is good, and then everything to the right of 1 is good. So these parts of the intervals, right, just the purple line, that would go from negative infinity stopping at -1, not included because it's an open circle. Then I would unite that, starting at -1 again, but still not included, going to 1, that's the green portion of the line, and then unite that, starting at 1, and this would go to infinity. Ran out of some space there, but it still works. And that would be the domain in interval notation. But again, the unions there have excluded both -1 and 1, which is what it asks for down here, what values. The domain is all real numbers except these two here. So when you do this, remember, you get to ignore the numerators when you're finding these domains. In the future, we will want to factor and simplify them. But even then, we have to go back to the original denominators and determine what values will not work in the domain, because we cannot have denominators be zeros.